Hello everyone, this is Mirza. In this video lecture, we are going to revise grid chamber from 5th unit. As we all know that grid chamber is aimed to remove grit from wastewater. So basically it is part of primary treatment unit which going to remove grit from wastewater such as small metal pieces, silt, etc. If grit is not removed, it increases wear and tear of mechanical equipments and also occupies space left out. If grit is not removed, it will enter into the mechanical equipment. Okay, and also causes disposal problems. So that it is very important to remove grit. So now we'll see grit composes of inorganic as well as organic. The size of grit less than 0.2 mm, then the specific gravity is greater than 2.65. For example, silt such as clay, sand, cinders, broken glass, metal fragments, etc. So these all are inorganic. Right. So now we'll see the organic grit. So size greater than 2 mm, then the specific gravity will be 0.05 to 1.1. So try to remember this. So inorganic grit consists of coffee grounds, tea grounds, eggshells, bone pieces, etc., which is nothing but organic. So grit chamber is a long narrow rectangular channel. Okay, it's just like a sedimentation tank, but in grit chamber we are going to design a long narrow rectangular channel, right, with increased cross-sectional dimensions. So if I try to draw, it will be a narrow rectangular channel. Having increase in cross-sectional area, okay, dimensions. So this will be the width, depth. Okay, so next we'll see, so deacceleration flow velocity thereby given raise to settling of grit particles from wastewater flow. So as we know that it is a narrow rectangular channel, as the flow will deaccelerated, okay, which will be low velocity, then settling of grit will take place. Okay, right. The flow velocity should neither be a far lower as it causes settling of lighter organic matter, nor it should be so high as not to cause the settling of entire silt and grit present. So we have to make sure that the velocity should not be low or should not be high, because if it is low, lighter organic matter will also settle down. If it is too high, all the entire silt will settle in the grit chamber. Okay, yeah, so that 25% increase in flow velocity leads to scoring of settled grit. A 25% decrease in velocity will leads to settling of untargeted particles, that is inorganic matter. Therefore, the velocity control device called proportional flow weir. So we already know weir is a concrete barrier, a solid concrete barrier is providing at outlet of the grid chamber to maintain the constant flow velocity. Okay, yeah, we'll see the design criteria. Before that, for your understanding, so it will be a long rectangular channel having a weir here. So this is a weir. Length is generally designed for 7.5 meters to 20 meters depending upon the amount of sewage. Okay, so width will kept 2.5 meters to 7.5 meters and the depth will be 3 to 4 meters. So we'll see the design criteria. For design parameters, first we have to identify the velocity of flow, that is VH. So VH is generally ranges in between 0.2 meters per second to 0.4 meters per second. So best value will be the average of these two, so that if VH is not given in the question, the best value will be 0.3 meters per second. Cross-sectional area of the grid, the formula is width into height multiplied by Q upon VH. So VH is the velocity of the flow, Q is the discharge, B is the width and H is the height or depth. Detention time. So detention time for grid chamber is 1 meter to 3 meters. So the volume we can find, that is discharge multiplied by detention time. Depth we can take 1 to 1.5 meters. If it is not given, we can assume the depth. Freeboard. So this is the effective depth. The remaining is nothing but the freeboard is kept 0.3 meters. Length of the channel is generally increased by 20%. So as per design, the length of channel is increased by 20% as an allowance for inlet and outlet turbulence. So we have formula for detention time, that is length upon horizontal velocity, that is VH. And also we have another formula, that is depth upon settling velocity. Depth is nothing but the height of the chamber divided by settling velocity. So here VH is a velocity of flow, that is horizontal velocity, and Vs is a settling velocity. Okay.